Okay folks, welcome to this Using QGIS to Map 2021-22 Census Data from the UK Data Service. My name is James Crone. I work for the UK Data Service up in Edina in Edinburgh. So the aims for the session today are, we're going to use the QGIS desktop GIS application to map census data downloaded from the UK Data Service. There's three specific aims. We're going to create different types of mapping: a univariate choropleth map, a bivariate choropleth map, and an area cartogram. See, this is a journey, so the objectives are to create those different types of visualization. And along the way, we'll learn various things about the UK Data Service, how you use the data, and how you use the GIS application QGIS. So we'll first learn how to download data from the UK Data Service. That's the actual census data itself, and some census boundaries from different parts of the UK Data Service. We'll learn how to carry different types of data transformations on the data, and this is to prepare it for mapping in QGIS. We'll learn about some of the issues to be aware of when mapping census data, to make sure we create valid maps that are not misleading to our users of our maps. And then we'll look at how to use actual QGIS itself. And so if you've not used QGIS before, this will be an opportunity to find out what QGIS and what you can do with it. And at the end, there'll be a short section where we just go over the sort of resources available in the UK Data Service to help you at using census data and mapping that census data. So in your joining instructions, you will have been provided with a link to a GitHub repo, which has a PDF workbook of all the steps I'm going to demonstrate during the demos today. The workshop's going to work from the basis I will give short talks, which will talk about the theory behind some of the things, and then I'll do demonstrations either using the UK Data Service website and the tools, or using some QGIS software, or doing some data manipulation in Excel or LibreOffice. I'm on a Mac and I've got Excel, so I'm going to do my data manipulation using Excel, but you can also use LibreOffice Calc. And the choice is up to you. You either follow just what I'm doing on screen and try and do it yourself on your own machine, or you can just watch and then maybe do later after the workshop, because I say you'll have access to the workbook, so you can always go through it afterwards in your own time. So I'm going to first give an introduction to the census itself. So the UK census is a decennial census, and it happens every 10 years. Within the UK Data Service, we mainly support the census from 1971 through to 2021 and 2022. In 2021, 2022, in Scotland, because of COVID, they did it a year later in 2022, whereas in England and Wales it was 2021. So that's why there's a difference there. The census itself, in the old days, it was done by people would get a paper form through the post, or a enumerator would come around and ask them the questions. It tends to be done online now, but the different questions are, there are household questions and there are questions about individuals. So the household questions will ask people stuff about the type of house they live in, the rooms in the house, and stuff, how they own the accommodation, like are they renting, are they mortgaged, or are they renting from a social landlord. Whereas the individual questions are questions about each of the individuals within that accommodation. So it could be age, sex, what sort of job they do, how they travel to work, etc. So on census night, which is usually in April, and the last one in England and Wales was 2021, Scotland will be April 2022, the population is supposed to fill in their census forms and submit the results to the census agencies, which in England and Wales is Office of National Statistics, and in Scotland is National Register of Scotland. And I say this is just some more of the sort of topics covered by the UK census. So you get these questions related to education, housing, health, and language or transport. And during the sort of demonstration of practice today, we're going to focus in on housing data, and we're going to look at accommodation type and tenure type. So sort of, are we looking at, is it flats or houses or semi-detached, and is it rented privately or is it socially rented? So when the census agency gets all the data, after census night, they do a lot of processing on the data. So they bring all the data together, and they produce output census aggregate data sets. And these output the different variables as either counts of people or households. And that data, that census aggregate data, is produced at different levels of output geography. And the smallest level of output geography is a thing called the census output area. And the output areas are specially created just for the census. And this is an example of an output area for part of Edinburgh. So each of these black polygons is a census output area, and you can see they cover a few houses or streets within a neighbourhood of Edinburgh. And the actual census variables themselves, you can see there's an output area code, which is a unique geographical identifier, which uniquely identifies a census output area, and then you have various statistics related to that output area, such as total population in this case, the number of households, the number of males, females, and are there how many detached or flats within that output area. And there's different types of census aggregate data. There's univariate aggregate data and there's multivariate. So the univariate census data just contains information about a single census variable, which could just be like accommodation type or tenure, whereas a multivariate data basically gives you multiple topics for each data set. So it would give you accommodation type but also tenure combined, and this gives you a much richer insight into the information. So you could take a univariate census data, like the method used to travel to work, which could be by car or foot or train, and then you could add additional variable, which would be how the occupation that people are doing, which would give you a multivariate data set. And that way you could do some sort of classification of different types of people's occupation, how they're travelling to work. So how are people who do skilled jobs travelling to their work, as opposed to people who might be working as in building occupations travel to work, so that you make some differences there. So multivariate data sets are a lot richer, whereas in this workshop we will simply be using univariate data set because it's easier to manipulate. But through the UK Data Service you can download both univariate and multivariate census data. So the UK Data Service itself provides access and training to economic and population and social research data. And the emphasis here is we provide access to both the data itself and the training around that data. So it's access to the data and then how you would use that data. And there's an entire training program of which this workshop is one part of. And within the UK Data Server itself, there's a specific part of us that purely support the census, and we are called Census Support. And we're distributed along, our census support is distributed along different institutions within the UK. So I'm up here in Edinburgh at ADINA, and we support the census boundary data. I have colleagues in Manchester who support the aggregate data itself, and I have colleagues at UCL in London who support the census flow data. And Jill is based at the Cathy Morris Institute in Manchester who support the microcensus microdata. And today we're going to look at using census aggregate data and census boundary data. And each of our different subsets of census have different applications in order to access different types of census data. So in terms of the census aggregate data tools, this gives you access to raw census stats themselves. CCAN will give you bulk access to the census tables. So you can download the census table, say for all of the UK or all of Scotland or all of England and Wales, but there's no ability for you to then to subset that data. So if you only wanted data for Glasgow or say Loughborough, you would have to do that subsetting yourself, perhaps in spreadsheet or a database application. Whereas a Data Explorer is a second UK Data Service tool which allows you the ability to create extracts from the complete census aggregate data sets. So they would allow you to just restrict your census data to Edinburgh or Glasgow or Loughborough, and to pick the actual types of the variables within the tables of census data you want. So it means you can be a lot more specific about the census data you want and where you want it for. Data Explorer currently provides access to 2021 and 22 data, and I think it also gives you access to 71 data. And we have a bunch of legacy applications that we're in the process, or the engineers in Manchester are in the process of translating or migrating that data from the legacy platforms into Data Explorer. The ultimate aim is eventually all the census data will be available through Data Explorer, and you'll be able to use the same tool to access data from 71, 81, 91 through to 2001 and 2022, possibly 2031 when that census happens. So I'm going to do a first demonstration, and I'm going to use the Census Data Explorer to download 2021 census data. So let me just minimize my slides, and I'm going to open a web browser. So I'm going to first go to the UK Data Service and show you how you access Data Explorer. So this is the UK Data Service. We have a data catalogue, which will allow you to search for datasets across the entire UK Data Service, including the census. But within the census itself, we have a quick link to our particular census applications. So within the data catalogue, if you click this quick link to census, it will bring up this pop-up window which lists our various census data applications. So you can either get access to Data Explorer. This is the census boundary here. This is another one we're looking at today. Or census flow data. And as I say, Infuse is a legacy census application which gives you access to earlier census data. And say you've got this CCAN which gives you access to bulk data. But we're going to use Data Explorer, so I'm going to click on Data Explorer. So this is what the Data Explorer tool looks like. You can see it's got 71 data and 2021, 2022 data. I think it also provides access to other non-census data, so data from our bank, but we are particularly concerned with the census data. These are quick link buttons at the bottom here. We can just click on these buttons and it will take you to like all Census 21, 2022 data sets. But for the purpose of this demonstration, I'm going to search for a particular type of census data for 2021 and 2022. I'm just going to refer to my handy workbook that I have given you all. And I'm going to look for 2021 census accommodation type. And so you can see there are 54 data sets of 2021 or 2022 census data which meet that term accommodation type. And see these are all listed here. But the one I want is this TSO44 accommodation type dataset. So by clicking the dataset, we get an overview. So Data Explorer will give us some metadata about what the sort of data is. So you can see it provides census data estimates that classify households in England and Wales by accommodation type. And as I say, at the minute, we're currently, if we were to hit the download button now, we would download the entire data set, whereas I want to split it down just for data, just for leads, because I'm going to show you how to create a map of accommodation type using the 2021 data for leads. So to split the data up and refine what we want to download, there are various filters at the left here, and I'm going to set these various filters to filter the data. So first, top level geography, I'm going to set England. Click apply, and you can see it adds a filter. Onto geographic grouping, I only want to download census data for a specific type of output geography. In this case, I'm going to download the data for wards because it's a relatively small geography. So I can click on the wards and divisions item and click apply, and this will tell Data Explorer to output our census data by wards. And having told that, I now have to tell where I want to download the data for. So again, at the minute, it's selected data for all of England and Wales. I want to only download data for Leeds. And what you have here is this This will basically show you all the sort of sub-geographies of England and Wales that we can download data for. At the minute it's currently quite unwieldy, so what you can do is you can do a collapse all, and then we can like drill down through the geography just to restrict to Leeds. So I know that Leeds is within Yorkshire and the Humber, so I can just do a drill down this way. I believe Yorkshire, I'm just going to check my PDF. Being in Scotland, I'm not particularly familiar with Yorkshire, but let's check. So Leeds is under West Yorkshire, and there's Leeds. And so I want to, each of these items here is an electoral ward within Leeds. And I could just manually go through and like click each one to add it to the data selection. And this is what, there's a different types of selection mode here. But what I'm going to do is change the selection mode to items and all items directly below. And this way, when I click on Leeds, it will select all the wards within Leeds. And now I click apply, and this will add that to my data selection. And so we've constrained to the type of geography, electoral wards, and we've constrained just to Leeds. And then the final filter is the actual census variables themselves. I'm going to want all these because these are different types of accommodation. So again, I can change selection mode rather than manually individually selecting these. So items and all types right below. And click apply. And as you can see, we've now set up our filters. Within Data Explorer, I can get a preview of the data by clicking the table button. And you can see we have geography area for Leeds, so each of these is a different ward, and across the columns we have the different types of accommodation type. And to download the data, we can use the download button here. The trick here is to make sure you use the filter data in tabular text form button. Because that will output the data as like a plain CSV that we can then use in Excel and then later use in our QGIS desktop application. If we use the unfiltered data, then basically Data Explorer will just ignore all those filters we set and we'll get the entire data set. If we use the table in Excel, then we get a lot of extra formatting information, which might look pretty, but it makes it hard to manipulate the data. So I'm just going to go for filtered data in tabular text format. And you can see we've downloaded the file. A quirk of Data Explorer is that it creates a file with a very long file name. So I'm going to make this more usable by shortening the file name. Just something a bit more manageable. Great. It doesn't make a lot of difference because yeah. Okay. Okay, I'm just going to go back to some slides now. And so we've downloaded our census stats from Data Explorer. The next step is having downloaded those stats, we need to do some data manipulation to prepare those census stats for mapping in QGIS. And there's like 3 things we're going to do to the data. We're going to transform the data from long to wide form. I'll explain what long to wide form later. I'm going to do some data normalization so that we don't produce misleading maps. And then I'm going to do an extra bit where I add an extra variable that summarizes the census stats to create a different type of map. These first 2 are pretty much essential whenever you use data from the UK Data Service because of the way the data is first provided, and then in order to normalize that data for mapping. This third thing, adding a categorical summary variable, is just an extra step that I'm doing, just so I can create a different type of map. But normally, if you're downloading data from the UK Data Service, from Data Explorer, you're going to have to do a transformation from long to wide form, and you're going to have to do some sort of normalization on the census variables before you map them in QGIS. And I'd say I'm going to do a manipulation in a spreadsheet, because spreadsheets are great at handling like tabular data. You can use like LibreOffice Calc or Excel. I'm on a Mac and I happen to have Excel, so I'm going to use Excel to do my manipulation. But you can use LibreOffice Calc. And in the workbook, there are instructions for doing the same operations in either LibreOffice Calc or Excel. And so this first transformation we have to do is to convert the data downloaded from Data Explorer from long to wide form. So data sets have different types of shape, which is determined by how the data is arranged into rows and columns. So Data Explorer will provide the data in what's known as a long form. And what you'll have is each record will contain a different census variable. And as you can see here. So here we have 3 different output areas. You can tell there's 3 because each one has a unique GeoID, which is this E05011384 thing. And each of the different census variables is provided on a new row. So if we've got 8 census variables, that for that one output area, it'll be provided on 8 records. Whereas what we have here is the same data set, but in the wide form. And here you get a single row, but each of the different census variables is instead shown in a different column. So we have again our same E05011384 output area, but this time each of the different columns provides each of the different census variables. And so within QGIS, is a lot better at handling data in this wide form, because as we'll see later, we'll download census boundary data, and for each of these output areas we'll get a polygon which we will attach to this table, and then we'll have the census variables of one record that has all the columns plus the output area geography by row, as opposed to this. If we were to add the geometries here, it would make the table a lot more complicated. But as I say, because the data comes in long form and we have to go to wide form, we have to do some data conversions within our spreadsheet just to make the data mappable. And this can be done in a spreadsheet application using a pivot table, which basically just groups the data by the unique geographic identifier. And I'll demonstrate that in a couple of minutes in Excel, although you can do the same thing in LibreOffice Calc. And then before we actually map the census data, we need to do some data normalization. The census data itself, so that's the counts of population of individual households or people, are just raw values. And so if we want to map the data, and we want to say we're basically creating a map that's comparing one area to another, then we need to do some normalization, because otherwise we'd just be showing the raw counts, which would not be very meaningful. And so there are different ways of doing normalization. We can divide by the actual size of the area itself, which would express the data as the value as a population density, so percentage of sort of people per hectare or kilometre squared. Or we can divide by the total population size, which would then express that as a percentage. So the percentage of people within its particular geography which live in flats, or rent from a private sector landlord, or travel to work by bike, or travel to work by car. And because it's a percentage, you could then compare that small area to another neighbouring output area, or against the country as a whole. And again, in a spreadsheet application, we can do that by just doing some sort of simple data manipulation. So we would have like the count of our private rent here, and we have the total, and dividing that the upper private rent by the total, and then multiplying by 100 would express it as a percentage. And then I say those first two are essential in order to be able to map the data, And this third thing, when I add a categorical summary variable, is just an extra step that I'm doing, just to like provide an extra thing that I can map. And what this is going to do is going to look across all the different census variables, so in this case for the different types of rent, mortgage, etc., and it's going to find the dominant one. So which category of house type is the dominant one for the output area? So in this case, it's going to be kind of as mortgage or private rented, and that's just a good way of summarising the data and say what's the dominant type of accommodation type within that output area. Or alternative, you could have like what's the least dominant would be a different one you could add. And what I'm going to do, again, I'm going to use this in Excel, and I'm going to calculate this column, and then I'll be able to map that and show a map of dominant accommodation type. So I'm going to have a second demo where I'm going to demonstrate how you do that preparation of the data that we downloaded from Data Explorer in Excel, and I'll show you how we do the pivot table, how we do the data normalization, and then how I create that categorical variable. And let me just find the data set we downloaded. So accommodation type Leeds 2021 census. And I say I'm going to open this into Excel, but again you can use LibreOffice Calc. I'll just increase the size of this. So this is the raw data we've pulled down from Data Explorer. There's quite a lot of columns here, a lot of like metadata, so it'll tell you the table of data came from, the top level geography. The important thing is the geographic area one, because that each of these, it will tell you what output area that record is related to. It will give you the localized name for that output area, or I think these are actually wards, so the actual ward name. And then it will give you the different types of accommodation type. So in this case, detached, semi-detached, terrace, and the always value is the actual count, so the actual census variable for those different types of accommodation. And I say what I'm going to do, at the minute this is in long form, I need to convert it into wide form, so I'm going to create a pivot table in Excel. And you do this using the Insert Pivot Table menu. So in Excel, Insert.
James, are you able to maximise that spreadsheet?
It doesn't really increase the size. Is it still quite hard to see, or?
I can see it, but others might struggle.
I think it's just the actual, yeah. Okay. Yeah, so insert and then pivot table. And so there's a pivot table field here where we have to define how to create the actual pivot table. So we're saying how do we want to aggregate the data. And so what you do here, on the top here are listed the different fields within that spreadsheet, and there are different boxes here which controls how the pivot table is constructed. So you just have to drag them from the top here to the different boxes. So I will first grab accommodation type 8 categories and drag that to the columns box. Jog area, that as I say is the unique set of geographic identifiers. I will grab to rows. And then you want the actual observation values themselves, so the actual counts of the census variable, or the values. And what you can see is it's aggregated that data so across the different 8 variables by the geographic identifiers. So we end up with like one row per unique ward, and each of those unique rows has the different columns of the census data. And we get a grand total which sums the values, sums the columns, and then sums of records. So what I'm going to do here is then grab this data, so do a copy and then create a new sheet and then paste the data into that new sheet. Let me just increase the size again. And what I'm going to do now, I'm going to just rename some of the columns because they're quite long. So this row labels 1, I'm going to rename to Ward Geo ID, so Ward Geographic Identifier. This rather lengthy a caravan or from a structure temporary structure, I'm going to rename that to caravan because detached, it's probably okay if detached, but I'll just make it detached with a small d. This very lengthy one, I'm just going to change this to comma B. This is all explained in the PDF. This is just going to be flat. This is a shared H. Again, another lengthy one. It's I'm going to just change this to SCH or warehouse, semi-detached will just become semi-det terraced. Again, some minor tweak there. And grand total, I will change to total. Great. So I say these are raw census counts, and we want to normalize each of them by the total population, so they get expressed as a percentage. So I'm going to create another 8 columns. And each of these will become renamed as prop, detached prop, and you can do the same for the other ones, just so that it's then clear that we have the data as provided as the raw count and then as a proportion. And so to do the actual conversion itself, we enter an Excel formula. So we do the caravan one first, so equals, so the raw value, which is C2, divided by the total, and then just multiply by 100. So that's expressed the value as a percentage. So we've got 3,000 divided by 9,000 gives you a percentage of 32%. And we want to use that same formula across the other columns. And so to do that, we're just going to edit the formula slightly. And just anchor so this way we can use it across the other columns. So what I did there is I just inserted a dollar just before the column so that it still refers to the total when it applies it to all the ones. So if I just drag across, check. Oops. So let's just check. Yeah, so we've gone D2 divided by J2. Yeah, is that correct? D2, no. Okay, I got the first one wrong. That should have been B2, not C2. Okay. Sorry about that. Now that's correct. So detached is C2 divided by J2. So column is D2 divided by J2, that's correct. Flat, we'll go E2, yep, divided by J2, correct, okay. Final check, terrace, column is I, yep, so we've got I2 divided by J2, correct, okay. And then we can just fill the other records. And let's just do a check, so B31, yep, divided by J31, yep, correct, okay, and then we just populate the rest of the records. Again, let's just pick one to randomly check. So semi-detached, so column is H, so you've got H23 divided by J23, H23 divided by J23 times 100. Yep, that's correct. Great. And so that's expressed all of those census variables as a proportion, so as a percentage. And so we've done our transformation of the pivot table, we've done our normalization. In the final bit, I'm just going to create that categorical column, which in each case will tell you what is the dominant census variable for each of the wards. And again, this is another, I'm going to use another equation to do this. I'm going to first give you a column name for this, and I'm going to call this dominant accommodation type. And it's quite a lengthy expression, so I'm going to grab it from the actual PDF. So if you just bear with me whilst I look for the workbook. And so this is the same PDF that you will have. And this is the equation we're going to use to do the categorical summary variable. So I'm just going to copy that. And put it into that cell. So what you can see is the equation that's told us for this record, this ward, the dominant type of accommodation, i.e. the one with the highest percentage, is the semi-detached, which if you look at the data is the case. And again, I'm going to want to, just to make this clearer, I'm going to replace the dash prop, I'm going to get rid of that in the actual text, and I can just do that by editing the equation slightly and wrapping it with a substitute. So just edit it and substitute, and I'm going to tell it to substitute the underbar prop bit with nothing. So and so you can see it just makes the text a lot cleaner. So it's got rid of this, like the prop from the column, and that just tells it that the dominant accommodation type is semi-detached. And I want to copy the same formula down the rest of the columns. So again, I need to edit the formula just to anchor some of the ranges with the dollar symbol. So referring to the PDF, I will add $1 here, just to anchor what it's referring to. And so that's still correct for that one, and I should now be able to copy and paste to the rest of the records, and this will now refer to the correct data. So again, a quick check. So for this ward, it reckons the dominant one is detached, and if we look along, yep, the dominant one is 41%, so that seems correct. So we've done manipulating the data in Excel. If you're using LibreOffice Calc, things will be very similar, although the things might be different places on the menu system. And I'm now just going to save this data, and so later we can manipulate it in QGIS. So save as, comma separated values, save. I want to replace it, yes. It will complain multiple things, but I only want to save the current sheet because that's one I've been manipulating, so I can just OK that. Now I just close Excel and go to wherever my data was. I will open that in something. Yep, so this is our data. That's what it looks like. We've got all our proportional value and our dominant accommodation type. So that's the census aggregate data. In order to create maps, we also need to download some geospatial boundary data. I'm just going to go back to the slides and do some more talk about geospatial data. So in terms of geospatial data, it's used to model some aspects of the world. Different types of geospatial data, if you've never come across it before. Vector data, which is it's like point, lines and polygons. Raster data is typically used to represent like satellite imagery, digital terrain models. It's essentially a gridded data set. Each cell could represent an area of elevation, or like a part of a satellite data set, or it could be like temperature or water or something. Geospatial data is what's special with geospatial is it's spatially referenced. Data is provided for a particular what they call spatial reference systems. So here in the UK, we use Ordnance Survey data or data from the Ordnance National Statistics. It uses a thing called the British National Grid that locates that data within the UK. If you're using global data for, like, say, all of Europe, that would use like a thing called WGS84, and that data uses a different sort of spatial reference. There's a whole plethora of different types of geospatial data formats. There's a thing called shapefiles, which are like the sort of almost the Excel of the geospatial world. We'll look at a few of these formats as we go on. There's a bunch of geospatial standards which define how spatial data is created and shared. There's an entire discipline called Geographical Information Systems, or science. And there are various what they call GIS software applications which allow folk to create, manipulate, and do things like create maps, or do some data manipulation, or what they call spatial analysis. A commercial well-known one of these is called ArcGIS, and there's also an open source one which we're going to use today called QGIS. QGIS has been around for quite a while now, and despite the fact that it's free, it's incredibly powerful. And has some great features, and it's ideal for doing sort of census data, so mapping census data. In terms of the census output geographies, so as I said before, The census aggregate data is output a range of different small areas. So I say we download the data at ward level. You also can get data at what they call output areas, or lower super output areas, or middle super output areas. And together these different output geographies form a census geography hierarchy, from the smallest, from the output area, up to LSO, to MSOA, to ward, to district, to county, to country, to nation. But the thing you have to be aware of is this thing called statistical disclosure control, which means that not all the census topics or the census tables are available at all geographies. So you might find that there are certain possibly disclosive census variables which could only be output at like higher geographies, like ward or district, and would not be available at output area level, which might have an effect on the sort of research questions you can ask. And this is just an example of what these census boundary data actually is. So a census boundary data set is a polygonal geospatial data set that just tells you on the ground what the output geography is like. So on the left here we have a council area boundary for Glasgow. On the right we have the much smaller census output area boundaries. We also have a concept of a thing called a geographical lookup table, which allows us to relate the different types of census geographies together. And this can be useful if you want to make some transformation between the different types of census geography. So you might have data at output area level, you might want to convert it to data at ward or district, and then you can use a geographical lookup table which maintains relationships between output areas and wards, or LSOs, or super output areas. Within the same census, there are also a set of lookup tables that do the same across census. So you can make lookups between output areas in 2020, 2022 and 2011, but you have to be aware there are some, because the geographies tend to change over time, they're not always one-to-one exact. You just have to be aware of that. But and you also get a type of geographic lookup table called a postcode directory. So a lot of data which you may be manipulating from, like surveys, which is output using a postcode. And what a postcode lookup table does is it relates postcodes to other type of geography. So you might have a postcode of EH104EL in a postcode directory. Each of the records for EH104EL would have a bunch of other columns which would then tell you the geography that postcode fell within. So that might be the census output area for 2021, or the electoral ward for 2011. And that way you could then use that lookup table to relate your data at postcode level to census itself, and then use the census to add context to your other survey information. And the postcode geography lookup tables, as well as the other census geographic lookup tables, are all available through the UK Data Service. And so we looked at Data Explorer from the Manchester team. We're now going to use one of the boundary data download tools, which I am responsible for looking after at ADINA, to download the census boundary data. And we're specifically going to use the boundary data selector tool to download the electoral wards for Leeds that we can then join to our census stats in order to do some mapping. So yep, it'll be another demo where I'm going to do some download of census boundary data from the boundary data selector. So I'm going to go back to the UK Data Service. Let's maximise my browser this time. So I'll try and increase, so zoom things in a bit. And again, to access the boundary data selector, we can use that quick link. So data catalog, click on the census lozenge or black thing. Yep, up pops the pop-up, and we want census boundary data borders. And this is the boundary data selector. So the boundary data selector allows you to look through the different boundary data sets we provide. And again, you can either download the complete data set, so we could download electoral wards for all of England, or in our case, you actually want to drill down and only obtain the electoral wards just for Leeds. So it's quite a simple application. It's got two tabs. There's a what and where, where you tell it what data set you want and where you want it for, and a format tab that lets you change the type of geospatial data format the data is provided in. I'm really just going to use the what and where format because it will default to providing data in shapefile format, which for our purposes of using the data in QGIS is fine. So there's three drop downs on the top here, which will control the data set that's listed. So I want data for England, I want electoral data, and 2021 and later. So you can see it's come back. We have a choice between electoral wards and parliamentary constituencies. So I want the electoral wards, list areas, and like the Data Explorer, we can now drill down through the sub-geographies to restrict the data purely to Leeds. So again, similar to Data Explorer, it's Yorkshire and the Humber. And again, we want Leeds. So borders, boundary data selector, we've told it we just want data for Leeds. And if we hit this extract boundary data button, it's going to go away to the database, pull out the features, and then dump it as a shapefile. So that's done that now. Just minimize my browser. So it's our data. I just open it. It comes as a zip file, and you can see it's a shapefile. So a shapefile is made up of what they call is these four different individual files. It's a .prg, a .dbf, a .atz, and a .shape. And the important thing when you deal with shapefiles is you have to have all four of these files in order for the data to work. So if you were to copy this to somewhere else, you'd have to make sure you copied each of the four components to the same place. Otherwise, if you try to open the data in QGIS, it would complain because it wouldn't be able to find the rest of the data it needs to show the data set. There's various other things that we get provided with the download from boundary data selector. A simple readme just tells you those files, where it's for, and sort of the folk who are support the service. And this terms and conditions file here, which tells us specifically, because the data is open, it's released under the Open Government License. And in order to use Open Government License data, one of the conditions is whenever you use that data, you have to include an attribution statement that tells you where the data came from. And we'll see this later in QGIS when we're going to create a map, and we'll go back to this file and insert that copyright statement into something we create in QGIS. So that's our data from QGIS. Oops. Just find my slides again. So let me grab the boundaries. I'm just going to grab some other data from the Ordnance Survey. And this is like contextual, it's going to give us a contextual background map that I'll add to QGIS so that when we overlay that, we bring in the census boundaries, we'll have some context just to add to make our map better. And I'm going to grab this data from the Ordnance Survey. Again, this is open data, so the Ordnance Survey is Britain's national map agency. And they have a website where you can download some of their open data sets. And so if I just Ordnance Survey, and what they call it is the data hub. And so this is the OS Ordnance Survey data hub. And they have a bunch of, they have open data here. and it lists various open data sets they provide. So they've got stuff from the British Geological Survey, sort of rock type and stuff related to soil. But we want actual map data, so you can change the providers from British Geological Survey to all. You just want the Ordnance Survey, and this is the data set we want. This 1 to 250,000 square kilometres. It's like a road atlas. It'll provide some nice context for our boundaries. So I'm just going to go to the download page and hit the download button. And this is going to download data for all of the UK. And this is raster data, so these are just like images. So let me just download that. And I go to my downloads. This is the Ordnance Survey data here. It's called it's a zip file, so I open that. And if I go to the data itself, it consists of this mapping as a bunch of like separate, what they call image tiles. So I can try opening one of them here, just in like my Mac data preview, so you can see it's basically this is a 100 kilometre by 100 kilometre block of map data. In this case for Land's End. So that's, we've got data from the UK Data Service Data Explorer, UK Data Service Boundary Data Selector, and the Ordnance Survey. I'm going to now open QGIS and show you how to use QGIS, and we're going to add all these datasets to QGIS. We're going to have a break at 10 past 11, but before that I'm just going to add the data from our various datasets into QGIS, and then after the break we'll get on with actually doing the mapping the data in QGIS. So first I'm going to start QGIS. So I'm on a Mac. I'm on a fairly recent Mac, so I've got QGIS 4. I think in the instructions they told you not to use QGIS 4, but it seems to work okay. I think I will have to manually edit the instructions for next time to say that. So this is QGIS. Let me just... unfortunately, I don't think I'm going to be able to make it much zoomed in. So a lot of these menu things may seem quite small still. So you just have to, if you don't manage to follow along now, after the workshop, you've got the workbook, so you might want to do it yourself when you've got more time, if you sort of lose track of what's going on here. So this is what QGIS looks like. There's a bunch of it's like most of our like GUI applications. There's a bunch of buttons along the top here which you can use to do different stuff. There's what we call a browser window at the left here. These are different types of data you can add to QGIS. This main window here is a QGIS map window. So when we add data to QGIS, it will be displayed in this map window. And at the left here is what we call the layers panel. So each of those data sets will basically form a layer of data, and the different layers will be shown at the left here. I said before on that geospatial slide that the spatial data was provided in different spatial reference systems, and I mentioned the British National Grid and WGS84 for the globe. By default, QGIS will default to displaying data in WGS84 for the globe because it assumes you might want to add data for anywhere in the world. Whereas what we want to do is display data just for the British National Grid in the UK. So at the right here, you can see there's this thing called EPSG 4326, and this is QGIS telling us that it's assuming the data is going to be displayed in WGS84, and that the data you add is in WGS84, and that's not what we want. You want to tell QGIS to display our data using the British National Grid Spatial Reference System. So the first thing I'm going to do, and this is like in your PDF workbook, it will tell you, is to change this from EPSG 4326 to EPSG 27700. 27700 is a code for the British National Grid. So to do that, I just click, and you can see it brings up this dialog saying Project Coordinate Reference System. And I'm going to set that to British National Grid 27700. You could also set it to any of these other ones if you want to do. You might be downloading data for America, like in Idaho, which has has its own unique spatial reference systems. There's a whole load of different spatial reference systems which have different purposes. But for our case, we want data in British National Grid, so we're going to set it to EPSG 27700. So there we go. So we've got our data in 27700. I'm now going to start adding data to QGIS. So I'm going to first add that raster data that we downloaded from the Ordnance Survey, that backdrop mapping. So to add data to QGIS, use this button at the top left called Open Data Source Manager. So if I click that, up pops this dialog. And this is called the Data Source Manager. We tell QGIS where to source data from on our local machine, or from like outside our local machine, like from web services or etc. And you can see down the left there are all the different types of data we can add to QGIS. So I'm going to first add the raster data by clicking the raster option. And here we specify the location on your local machine where that raster data is. So for me, it's on my downloads folder, it's RAS 250 GB data, and I'm now going to add one of these map blocks to QGIS. On the one I want is SETIF, because I know this is for Leeds. So select the SETIF and click Open. That's fine. QGIS reads the file. It's grabbed some metadata that's used that will display the data. I'll just click Add, and we get our dataset shown. By default, when QGIS draws raster data, it doesn't always show it particularly clearly because it's optimized for like speed rather than like the actual quality of what's being shown, which can slow things down. But so if we zoom in, it can be quite distorted and blocky. And I want to make that clearer, so I can tell QGIS to draw the map a lot clearer, and I don't really care if it draws it a lot slower. So again, as I said, what we have here loaded is one of our data sets in the map window, and we have the layers panel at the left that's listing our current layers within QGIS. And so you see it's add a layer for SE, which is our map tile. Within the layers panel, you can select any of the layer items, i.e. the different types of map, and you can right click and go to Properties, and that will open a properties window for that type of layer, and we can use that properties to set different properties of the layer being displayed. We will use this later on when we want to create our census maps. So the minute it's collected symbology, and in order to tell QGIS to display the raster data more clearly, I can use this resampling option here. And so the minute it's say zoomed in, nearest neighbour, so it's applying some raster operation to tell it how to display that data. And I'm going to change this from nearest neighbour to cubic. And oversampling, it's quite low, so I'm going to change that to a lot higher. And this basically just tells QGIS to draw the raster data at a much higher quality, acknowledging that there will be a hit to the actual render speed or the draw speed of the map. So I'm going to hit Apply. And you see now QGIS redraws the map. It's slower to draw, but it's a lot more higher quality. And so this is Leeds here. this is going to be our area of interest for the rest of the workshop. I'm now going to add the other census data to QGIS. So again, remember we downloaded the census boundaries as a shapefile from Boundary Data Selector, and we downloaded the census stat as a CSV file from Data Explorer. So I'm going to first add the boundaries. So again, same deal, use the Open Data Source Manager button. This time we want to use the vector, because it's vector dataset shapefile. Again, navigate to the data, boundary data, and the one we want to select is the shape, i.e. the shapefile. Open that, add, and close, and here are our boundaries in QGIS. So because it's a vector dataset, we can use some of the buttons along here to interrogate the data. So this I is called identify, and it allows you to identify the feature on the mouse click. So I can identify, click on one of the polygons, and it will show you various properties of that polygon. So we can see it's for this particular ward has this geographical identifier, and it's called Harewood. At the minute it's not any census data because we've not actually provided any census, it's just simply the boundary. And we can do stuff like we can select one of the polygons, or we can select a bunch of the polygons. And we can do sort of basic spatial analysis. So we've got a polygon selected. We might want to find all the other polygons that are connected to this selected polygon by doing a select by location operation. And so when we do that, QGIS finds all the other intersecting polygons with our selected polygon. Let me just add the actual census stats themselves. So again, Data Source Manager. This time you want delimited text. So browse to the data set. In this case, our census stats, which is just the CSV file. I click Open. So we get a preview of this the census stats CSV. You can see our lovely proportional data expressing the values as proportions, and our categorical thing that telling us the dominant accommodation type. Under geometry definition, make sure that's set to no geometry, because the CSV file doesn't actually contain any geometry itself. That's in those polygons. We're going to join them later. And again, just hit add and then close the dialog. QGIS will add that census CSV to the layers, and so we can open the attribute table in QGIS. So you can see it's loaded the CSV into QGIS, but it's not showing a map view because at the minute it's looking for the map. So that's our data in QGIS. We're going to take a short break now for 10 minutes, and then after the break we'll now go into the actual fun stuff. We're doing the actual mapping of this data. I make that 11:25, so we're going to start again. So far we've grabbed data from the UK Data Service. We've done some manipulation of that data in Excel, and we've stuck it into QGIS. We now want to go into the process of actually creating some mapping. So what we're going to do is we're going to create a thing called choropleth map. And I'm just going to give you a quick introduction into what choropleth mapping actually is, although you may well be aware of this already. So at the left here we have like a bunch of boundaries. I think these are Scottish council areas. You can see each of the council areas has a geographic identifier that's the S12 code, and it has some random stat attached to it. percentage of something, I guess. So 5.27, 8.2. Not particularly useful as a map, and quite hard to see what the differences are. And so that's where chlorophyll maps come from. You basically shade the polygonal data based on the actual attached variable. And so high values get shaded like dark green in this case, or lower values light green, and it allows you to quickly look across the data set and look at the variation of the census variable. So then you can compare what the census data is like in say Edinburgh versus the rest of Scotland or the rest of the UK. I think on the left here, this is showing the percentage of people who work in the forest industries. So not surprising in Scotland, that tends to be the Scottish borders, or in Wales, the sort of rural parts of Wales, and less people employed in forestry within the City of London, for example, or the UK Scottish Central Belt. Whereas I think on the right we have a chlorophyll map which is showing the percentage of people, possibly house type, and so the dark areas are where it might be there's more folk living in flats, the light less folk living in flats. So there are some limitations of the chlorophyll map we have to be aware of. They tend to imply, because you're just shading the entire polygon the same colour, that the underlying population is distributed uniformly across the polygon, which in reality that's not the case. So as you can see here, this is some aerial photography, and we've got these black boundaries shown on top, and the population is really only in the sort of like the upper areas of the polygon around here, but there are areas of like green space, for example, and areas of industry where there's no one living. So the chlorophyll map as is can be a bit misleading in terms of like, because the data is not uniformly underneath it. So as we'll see at the end of the presentation, there are alternatives to the chlorophyll map which have become more popular among some of the sort of ways of visualizing the census data. So just to be aware of this limitation. The chlorophyll map is still great though as a way of like getting a quick insight into how the census variable varies across the entire data set, and to make quick comparisons between a small particular region of interest and the UK as a whole or whatever. And it's a useful skill to be able to create chlorophyll maps in QGIS. And so that's what we're going to do over the next 20 minutes or so. So what on the right here is a PDF that I've created in QGIS using all the census data we downloaded this morning. So this is showing the percentage of households in Leeds living in flats as recorded by the 2021 census. And if you're following the workbook, you'll be able to create this PDF yourself, and you'll also be able to do this. And the idea is that then you'll be able to download any other data set from the UK Data Service, Data Explorer, and then build your own PDF maps for any other data set that's available in the UK Data Service by doing the same sort of things and those same transformations in Excel and those manipulations. And so the components of a chlorophyll map are the map census variable, so those stats from Data Explorer, the census geography boundaries that we download from Boundary Data Selector, and making a linkage between the stats and the boundaries, doing a chlorophyll map classification, so we have to tell QGIS how it should shade each of those polygons according to the census variable, and then a colour ramp, so what sort of, should we use blue to display the different values, or red or green or whatever. And then, as I said before, we always have to include a data attribution statement, because although the data that you download from the UK Data Service is open access, there are conditions of using that open data, one of which is you attribute the provider of that data. So this is why on my PDF here, and as well as all my maps that I'm showing in these slides, there is an attribution statement at the bottom that tells you the data came from National Statistics under an open government license, and it contains Ordnance Survey data because the Ordnance Survey are the ultimate source of those census boundaries. and there's a Crown copyrighted database or right copyright statement. So when we talk about linking stats to census boundaries, again, just to reiterate, we have our census stats download from Data Explorer. They'll contain like this geographic identifier column, which is those 9-digit codes that tell you within each row what is the unique ward. And then a bunch of census boundaries that have the same codes, and because they're the same in each case, we can link the data to one another. Within the census, they should be fairly consistent between data sets. If you have other non-census data, so you might have random neighbourhood statistics data that was produced outside the census that you might say be trying to relate to electoral wards, you can often find there can be slight differences as the geographies have changed, and so you might not always find there's a one-to-one link between your data and the particular geographies. So you just have to watch and make sure there is a one-to-one link. And so I'm going to hands-on demo of just in QGIS making that join from our census stat to our census boundaries. So minimize some of these windows. Back to QGIS. Again, I think QGIS, it might be quite hard for you to see what's going on here because I've got quite a high resolution screen. So again, as I said before, we've got the layer panels here, and I can select the polygon layer. So these are electoral ward boundaries. Right click and go to properties, and it will open that layer properties. And one of the properties is joins, so it tells QGIS what data is currently joined to the polygonal layer and what data do we want to join to the polygonal layer if there's none currently added. And we want to join those census stats to the census polygons. And so we click the add button and it will add a vector join. So I can just make this window a bit wider so you can see what's going on. So it's pre-selected that this accommodation type leads 2021 because that's our CSV file. And it's been clever, and it's just picked the first column in the CSV as the geographic identifier, which is what we renamed to wards GeoID. The target field is the field within the actual polygonal dataset itself, i.e. that shapefile, which also contains those geographic identifiers. So if I select the drop down, the one we want is Ward 2022 code. And if I do an OK, and an apply, and OK, and this time, again, in the layers panel, right click, and go to, but this time, go to Open Attribute Table. And this will show our polygonal dataset, but this time, we now have all those census stats added to the polygons. So that's again our lovely raw counts of the households, our lovely proportional values, and our dominant accommodation type. And again, I can use the identify button to click on one of the polygons, and it will show all the properties of those census stats on each of the boundaries. The identify button's a nice way you can just quickly step through the data and relate the polygon to the actual census stats. So we've got our census stats attached to our boundaries. Before we actually do the chlorophyll mapping in QGIS, we'll just go back to slides for a while. Oops. Yep, so we've done our table join, the stats attached to the boundaries. I'm just going to consideration some of the chlorophyll mapping choices. So we have So we have the choice of the census output geography. In our case, we've already made that choice by picking the electoral wards. The choice of chloropleth map classification method, and the choice of the chloropleth colour map ramp. So as I said before, the census output geography is available at different levels of output geography. But disclosure control means that not all the census variables are available at all levels. And the point, so this is what you can see here. This is the same census variable displayed at different output geographies. So we have census output areas here, lower layer super output areas, and middle layer super output areas. And the thing is, if you analyse the same, assuming the data is available at all levels, and it's not been impacted by disclosure control not making it available, you can get different insights into the variable by looking at different levels of geography. At the output area level, it might be quite noisy, whereas you zoom out, it becomes the data tends to get smoothed, and you will see more sort of regional patterns, and so you will therefore produce different types of chloropleth map at the different levels of geography. And that's just a case of finding the level of mapping what's most suitable for you. And also you may be looking at bringing in other data sets, so maybe environmental information, which may only be available at particular output geographies, because so you might have like pollution scores or something which may only be available at super output area level, and you're bringing that in to add context to the census data. And in terms of what a chloropleth map actually is, it's doing some sort of data classification. It's simplifying the data. So your raw data itself. So where's it going? Let me just find that spreadsheet. Oh, we've got it in QGIS. I can open QGIS. Yep. Yeah, so these are all just one of the columns is a whole variety for the 33 layers, 33 records. There's a whole range of values, and there's probably a unique value per record. And so when we create a chloropleth map, we're going to simplify the data by arranging it into 5 groups or 7 what they call data classes, just to simplify the data. So if I go back to the slides, if I can find the slides. Yep. And so we do a sort of data classification. We take the full range of data values and we classify into a set of what they call data buckets. And each data bucket has we set a minimum and a maximum value for the values within that bucket. And you can see that what's going on here. So down the left, we have the range of values, say from 3 to 93. And then what we do, we have in this case, I've set 5 buckets. And for each of those buckets, we set a minimum value and a maximum value that tells you when that data set value is within the bucket. So in our first bucket, we have it will take range of values from 3 to 20, the next bucket from 21 to 38, 57 to 74, and then the 75 plus. And then so all the records which have values between 3 and 20 will get put into this bucket. All the records values between 61 and 64 will get placed into this bucket. And this is a simple, what they call an equal interval classification, because each of the buckets is the same size, and so they all go from 3 to 20. So they all cover 17 values, in my case from 3 to 20, or from 21 to 38, or from 39 to 56, or 59 to 74. There are different classification methods, and it's the way they create those buckets which is different about each classification method. In some, the buckets may not be the same size, because they may where you have more data, you may have more buckets, or buckets that are smaller or have different minimum and maximum values. And so this is what each of these is what they call a different chloropleth map classification method. So that equal interval one I showed there and there's a whole bunch of different ones. And they basically are just controlling how those buckets have been formed and how the data is being applied to those buckets, and sort of how they're basically simplifying the range of values in the data in order to make the data more usable. And so chlorophyll map, in which we've applied some data classification, and then we've got 5 buckets, and again with a minimum and maximum value. And we applied to some colour ramp, in this case an orange one. So low values, the lowest bucket values have like a very white, whereas the largest value bucket is quite dark. And again, this thing, you can take the same data set and you can choose a different classification method and you will produce a different sort of map. So it's just to be aware that if you pick a different classification method, with the same data, you can produce a different kind of map, and you just and you can also when the number of buckets you also pick also produce different types of map. So if you have a classification of 5 buckets, you will get a different looking map than if you have one with 3 or 7. So that's what you can see here. So we have the same data set. We're using the same sort of classification method. I think it's probably equal interval, but we're varying the number of buckets used between 3, 5 and 7, and when you do that you get a different sort of map, just because the way the data is being allocated to those bins, and then the output map gets shown. And on the left, same deal. This time we've got the same number of buckets of 5, but we're using a different classification method. And again, you get a different sort of map depending on the classification method. And the point is that no classification method is right or wrong, but you just have to be guided by what your actual data is like in order to pick the classification method to use and the sort of map you want to construct. And the idea is not to create a misleading map. And we'll see that in QGIS, how you can actually look at the underlying data to see how it's been classified. And so that's the classification process. So that's telling us how to bucket the data. You obviously then want to pick the actual colour ramp to use. So sequential is what you normally use for chlorophyll maps. So that's from light to dark. So you have a green sequential colour map from light green to dark green. Diverging would be a case if you're it might be data around a mean or around 0. So you might have minus values to the left and plus values to the right, so increasing plus to green, to light to dark green, diverging sort of light brown to dark brown, and a qualitative is a little more of a categorical map. So this could be a land cover map where you just divide blue for the sea, green for forests, orange for mountains, red for buildings. And so go back to QGIS and we'll actually get on with actually creating some chlorophyll maps. So I'm going to first create a categorical map, and that's going to use this semi-detached column here. That was the one that tells the dominant type of accommodation. So again, left click the layer, into properties, and this time you want symbology option. And it's like the symbology controls how the map is being displayed by QGIS. At the minute it's showing a single symbol, so it's defaulted. What it defaults to will change each time. It just picks a random colour, and in this case a single symbol. So it's drawing all the polygons the same single symbol, in this case orange. And I want to change this, which I use here, to the different types of visualization. And I'm going to first use what they call a categorized, and I'm going to select that categorical data we created, or dominant accommodation type, and if I hit the classify button, QGIS will look at the underlying data and will create a new color class for each of the unique strings essentially within that column. So our semi-det or flat terraced, whatever. which you can see is what it's done here. Within QGIS, I can just it always adds in all of our values, because in some people have data sets which contain data with null values. In our case, we don't need that because all our records are populated. So I'm going to get rid of that. So you can just select the all other values and do delete. So the values here are those. That's the actual strings shown in that dominant accommodation type column. A legend is on a map. It tells you what the map is actually showing. It's like a label of each of those classes. At the minute it's just used the value, but I want to make that more readable. So you can just, in the QGIS, you just double click under legend, and then you can edit what it actually shows as a label for the class. So I'm going to put detached houses, flats, semi-detached houses, and terraced houses. And you can also reorder things here. So if you just select one of them and then just move them around. So let's put detached houses, semi-detached houses, terraces, and flats at the bottom. And we can also change the colours for each of the classes. So detached houses, I don't know, it goes to dark green, semi-detached, light green, terraces, a lovely shade of orange, and flats, let's go for like a sort of pinky colour, and just apply that. And so now QGIS has redrawn the data using that categorical classification. And you can see that in Leeds, in our electoral wards, as you might expect, within the inner city, the dominant accommodation type is either flats or terraced houses, reflecting the urban density in the city centre. I can make this more readable if you go to the layer properties, and then you can change the opacity from 100% to something less than 100 to 80%. And what this will make the boundaries sort of semi-transparent, so you'll be able to see the ordnance survey background mapping shining through the data. And that way it's a lot easier to see the Leeds city centre and the suburbs. And you can see that in the suburbs the domination type, house type, is detached homes and semi-detached house, just reflecting, I guess, the lower density areas of the city. So that's our categorical map. If we want to create an actual choropleth map now from the actual one of the census variables, I'm going to show the percentage of data of people who live in flats. And so the same deal, left click the item in the layer panel, so left click to select it, and then right click and then properties. And again back to the symbology, and this time change from categorized to graduated. And again pick the column we want to use to draw the map, and I want flat. But I want flat proportion, so this is our percentage value rather than actual raw flat values. And I can just go away with the defaults and hit the classify, and QGIS has gone away and has applied one of those classification algorithms to bin the data into, in this case, 5 bins, and it's set a minimum and max for each of the classes that determine which records values get attached to each bin. And what you can look at is the underlying data, so the histogram. So the classes tab, click on histogram and click on loads value, and it will show you the distribution of your underlying data. And this can help guide you in the sort of classification method to use. So is your data, is it mostly in lower values or is it upper values? And then that can help you define. I'm going to pick a natural breaks one classification, and I'll increase the number of classes to 7. And you can see that QGIS will calculate the class breaks. And I'm also going to change the colour ramp from red to blue, like so. And if you just apply and OK, and you can see that QGIS has now redrawn what was a categorical map into a univariate choropleth map. It's univariate because it's a single variable being mapped. And you can see that, perhaps unsurprising, in Leeds, the wards with the highest proportion of folk living in flats tend to be in the city centre, or right in the city centre. And that lessens as you go towards the suburbs of the city. And what we can now do is create that PDF in QGIS. And within QGIS, the way you create a PDF output, which you might say want to incorporate into a document you're producing or send to someone in an email, is a thing called the Layout Manager. And to access the Layout Manager, you go to Project and Layout Manager. And you just accept New from Template and click Create. And you have to give the layout a title, so I'm going to give it the title of My Census Map. And what pops up is a bit like if you've used PowerPoint, you get like a black canvas in which you can then sort of drag elements on in order to create your print layout. It defaults to landscape. I want to be a PDF. I want portrait. So I go to Layout Properties. Page Properties rather, sorry. Page Properties, yeah. Layout Page Properties. So Layout Page Properties. I change orientation from landscape to portrait. I'm just going to maximize this, the layout window. So that, oops. Okay, and so down the left here, you have different elements you can add to the layout. So I'm going to first add a map, so which is this one here, which is like add map, and you select the button and then drag onto the canvas, and QGIS will add to the layout what's currently shown in the map window of the main QGIS application, which in our case is a univariate choropleth map overlain against a backdrop ordnance survey map. And then we can add, again you can resize this and move stuff around. One of the first elements we want to add is an actual map legend, so that we can, because if we just gave this to people, they wouldn't understand what the different shades of blue actually mean. So you have to give them a legend, and a map legend just tells you what the actual map is showing. So we use the Add Legend widget. So again, we click on it and then drag a legend. And because QGIS is currently showing a raster dataset, it's added each of the colours shown on each of the raster background as a separate thing, which is really not what we want. So we can edit this legend to remove the legend for the raster, just so it just shows the class breaks for the choropleth map. And so to do that, under the legend section right here, we go to legend items. It's currently set to synchronize to visible layers, which means whatever you see in the map layout is slaved to what's showing in the main QGIS window. And so what we want to do is change that to manual, and that means we can now select the raster one and click delete, and it will still keep the raster map shown in the layout window, but it just removes all that the actual legend for the raster which makes our legend a lot more useful. And now we can actually go into the legend itself and start editing this, because at the minute it says 3.4 to 6.8, but what? Well, it's actually flat, but we need to tell the users of the map that. So you can just double click one of the legend items, and then you can just edit this. So percentage flats, percentage. And I can do that for all the rest of them. Oops. Oops. Yep, you get the idea. So, flats. Flats. Yep. Percentage. Oops. Oops. And you can also double click here and change the actual title from, at the minute it's just showing the name of the actual underlying boundary dataset. We can change this to 2021 electoral wards. And the legend's updated, and we can move the legend around. And so now a user of our PDF can actually tell what's on the map. We can also add stuff like a scale bar. Not terribly useful because we're not going to use this map for navigation, but it still might be useful because by providing a scale bar, the user can tell how big each of these actual ward polygons is in the real world. So in terms of kilometers, we can add a north arrow just to help the user orientate themselves, and then we can add some text. So the first text we're going to do is add a title to the map. So maybe that was a bit quick. So again, from the left, you just click the add label and then drag a new label onto the canvas. Oops. And then you can write the text. So I'm going to go a map showing census data for Leeds. And you can change the font to make the text a lot bigger. I might have to drag this out again. And maybe I can make that bold. And as I said before, an important thing we have to add is a copyright statement. And again, just add some text label. And as I say, go back to for our downloaded census boundaries into that terms and conditions document, and just grab the attribution statement, which is this one here. Just copy that into the label. At the minute, it's got the year as a placeholder, and we want to update that to this year's current year, which is 2026. And again, just increase the font. And so this way, we now have an attribution copyright statement for the data we're showing. And so there's various other things you add to the layout. You can add some decorations, I don't know, like a big star or something. That's not particularly useful. But again, in the QGIS documentation, there are various guides that tell you how to create nice looking layouts. And so what you can now do to export as a PDF is use the button along the top called which has got like the sort of acrobat symbol on it. I can just export as PDF and tell you where I want to put the PDF to. I'm going to just put that onto my desktop, my census map, maybe of Leeds, and do a save. And keep the defaults are fine. And if I go to my desktop, let's just minimize QGIS for a while. And here's my PDF. So here's my PDF of Leeds that I created in QGIS from census data, downloaded from the UK data service, and I could just email that to someone, or stick it in combine it in a document I'm creating. And again, you can do the same for any sort of census data you download from the UK data service if you follow this process. So I'm going to go back to some slides, I think, and we're just going to look at some other types of census map other than univariate choropleth and categorical maps. So let me just make these full screen again. So some other types of census map you might see, or indeed you can create in QGIS, are bivariate choropleth maps and cartograms. And there's also some census maps called asymmetric choropleth maps, which we'll look at some examples of later, but you can't actually create easily in QGIS. So the type of choropleth map we were showing, and which we indeed created in QGIS, is a univariate choropleth map, because we're only showing a single variable at one time. In our case, like accommodation type, so the potential of flats. A bivariate choropleth map, on the other hand, will show simultaneously two variables at the same time, which can be really useful for census data, because it means you can create some more interesting maps. And that's what you can see it right here. So at the top we have these two univariate univariate choropleth maps, well, one for poor health and one for unemployment. So in poor health, so low percentages of poor health are in grey, and as poor health increases, it's up to dark pink. Unemployment, so low unemployment grey, high unemployment dark cyan. Those two individual maps, but if you combine them and create a third map, so this time a bivariate choropleth map, we're showing the two variables at the same time. And so what you end up with is like this sort of thing, where we get combinations of purple and cyan. And so where both unemployment and poor health is high, you'll get a very dark shade of blue. Where they're both low, you'll get grey, and then the intervening things, you'll get different combinations of cyan and purple. And this is like in one single map, we're showing two variables at the same time, which can be useful for census data, especially multivariate census data, because again we can show multiple variables at the same time. The key thing with bivariate choropleth maps, though, is to make sure you pick variables that are related, because otherwise you could create some quite misleading looking things. A cartogram, on the other hand, in a normal choropleth map, we simply keep the electoral ward boundaries, the shape of them as it is, and simply colour those polygons according to the census variable. Our cartogram is a special form of map, where instead we actually distort and reshape the census boundaries according to the variable itself. And this can be really useful, like if you're trying to if you've got the case of Scotland, for example. So these are showing Scottish council areas, and as you can see in the central belt, the council area for Edinburgh is quite small, whereas the council area for the Highlands and Islands is massive. And so you can get, if you just show it as a choropleth map, the actual underlying geographies are quite hidden. And so instead we can create a cartogram which will distort or reshape the actual polygons according to that census variable, so that where the census variables are high, the polygons will be distorted more, and where it's lower, they will get distorted less. And so you end up with something on the bottom here, where the underlying polygons have been distorted, and so these large, the central belt polygons have essentially ballooned up and have become a lot bigger, whereas the highlands and islands, which are like lower populations, have been distorted less. And it's a different way of like viewing the data. And the important thing in this type of cartogram is that the actual topological relationships between the polygons has been maintained, so that so in this case South Ayrshire, which is down here, is still neighbouring East Ayrshire and Inverclyde, and that's the same in the output cartogram, so that you can still relate neighbours to one another. And so cartograms are quite feature in the wild for like visualising socioeconomic data. The Guardian features cartograms in its reporting for the EU referendum, 10 so years ago, which we're still living from. And also they featured prominently in this book called People and Places, which is a really nice book, which visualises the 2011 census data, and it uses all that, the data is all visualised as these area cartograms. It's a really nice book. And so what I'm going to demonstrate now in QGIS is how you can create a cartogram yourself of the sort we saw there, and also how you create a bivariate choropleth map. I have to caveat this, as we'll see, my version of QGIS will not currently allow me to create the actual cartogram, because I'm using a Mac and it's a new version of QGIS and a new Mac, and there's some issue with my particular install. But I will definitely show you the tool, and I'll be able to show you the cartogram that I pre-made the last time I ran this workshop 3 months ago in March, where it ran. So I'm hoping that in the next time you run this workshop in 3 months' time, I will have come with a workaround and I'll be doing an actual live demo of using this particular cartogram construction. But at the minute it's going to be a bit of a blue Peter. Here's one I did earlier. So let me just go back to QGIS, and we'll certainly look at how to create the bivariate choropleth map in QGIS. But again, the cartogram will be a pre-made one, so apologies for that. So let me just remove the layout, go back to QGIS. To create the bivariate choropleth, again we need a data set that has two types of variable in accommodation type and tenure type, which are not in our data we created. So for the purposes of this exercise, I created another data set which is in that data pack that you could have downloaded from the GitHub repo that we sent you in the joining instructions. So I'm going to navigate to that data set and add it to QGIS now. And it's actually a data in a geo package, which is a different type of data other than a shapefile. So here's my data pack. The directory structure here should be the same as what you download from the GitHub repo. And so what I have to first do is add to QGIS the geo package. So it's a geo package. A geo package is a special type of geospatial data set. In some ways it's an advancement over shapefiles in that you can have a single geo package that can contain different layers of data. So you add the geo package and then you connect to it, and then you can add the data set. And again, it's for leads. And if we open the attribute table, you can see we've got different types of column again, which are proportions. So the AT means accommodation type. The 10 is the tenure type. So basically we have those electoral wards for leads, and a bunch of columns giving sensitive variables on accommodation type, and a bunch of columns giving variables at tenure. And we're going to basically, in QGIS, create a bivariate choropleth map that shows one of the accommodation type variables and one of the tenure types variables together. And so In your workbook, it talks about how QGIS is really nice. It's an open source piece of software, and we can expand its functionality using a thing called plugins. And these are like community developed enhancements to QGIS that people have added to increase its functionality. And it just so happens that one of these plugins is one that will allow us to create bivariate chlorophyll maps, because by default QGIS will not allow us to create bivariate chlorophyll maps. So we use a plugin to do that. And there's also an additional QGIS plugin, the one that I can't currently get to work, which will allow us to create cartograms. And so to enable these, and this is explained in the workbook, you go to the plugins menu. And you can tell what plugins are currently installed in QGIS. So you can see I've got the bivariate one installed and the cartogram one installed. And you can also search for other plugins, and you can see there's a whole load of them. There's like, the thing with QGIS, if you discover it can't do something, you can normally find a plugin that will do it for you. And so in the case of the bivariate plugin, again, I'd go to the properties and go to that symbology type. It adds a new option to the symbology type of the bivariate renderer. So rather than categorized or graduated, I can go to bivariate renderer. And similar sort of thing that was on the slides. So we have to tell it what of the two columns to use to construct the bivariate chlorophyll. And I'm going to go for accommodation type of flat, and maybe private rented flat tenure. And if I click apply, QGIS will classify the data according to that bivariate classification. And you can see it's created a new type of legend for us, which is like these rather strange looking like grid representation. So again, where both accommodation flat is high and private rent is high, you'll get blue, and you'll get grey when they're both low, and you've got the intermediates for the different types of variable. And again, you can also change the opacity to make the OS data shine through and give more context, like so. And then were I to create a cartogram, using that cartogram plugin, QGIS will add a cartogram button to the main toolbar called Compute Cartogram. So you would click this, and up would pop this UI, and you basically tell the cartogram plugin which column to create the cartogram from. And so you might go for like, let's pick the actual correct so flat, and you would hit OK. If I hit OK here, I'm fairly sure QGIS will probably grind to a halt and then will die, which is not good for a demonstration. So I'm not going to do that. I am going to add the cartogram I created on my other Linux machine, which I know worked. So let me just add another geo package with this cartogram I created before. So and so that's what the cartogram plugin will create, is a cartogram. So as you see, it's distorted the electoral wards according to the accommodation type variable. And again, you can shade it. And that just gives you an alternative way of creating a cartogram in QGIS. So that's the demonstrations of everything in the workbooks of how you manipulate the data and create a univariate chlorophyll map, a categorical map, a cartogram, and a bivariate chlorophyll map. I've got some final slides, and then we'll maybe go through some questions, and then we'll bring the workshop to a close. So as I say, one of the problems with the chlorophyll map is the fact it implies the population is uniformly distributed across the extent of the polygon. An alternative to the chlorophyll map is what you'll see are what these things called asymmetric and mass chlorophyll maps, which are an alternative. And what they do is they basically use like an additional layer rather than the sort of the boundaries, such as a buildings layer, and then you basically shade that buildings layer by the census variable, so you get a much more realistic distribution of the population shown. And these are used a lot, and they've been used a lot for by the ONS and other organisations to display 2011 and 2021 census data. So there are two examples here. So this work was really pioneered by the folk at University College London, and this DataShine service. And that's what DataShine is showing. It's basically rendering, instead of the census data as a uniform chlorophyll map, it's rendering using a buildings layer, and that's what you see on the left here. So it gives you a more sort of realistic looking map. So for Leeds, so you get where the areas of like green space and stuff are not being shown, or in industry when there's no buildings. And I say the ONS have taken inspiration from this, and they use it to create census maps in their Census 21 mapping software, which these are both online you can look at, and they use a similar sort of visualization there. You can create these things in QGIS, but it can become quite involved, because you have to obtain a sort of UK-wide buildings layer, which can be quite large, and then do all the sort of like geometrical operations and processing to create the maps yourself. So it's just to help you if you have questions about census data, or how you in the future within the UK Data Service. There's a UK Data Service training program. This workshop is one of them. We will be repeating this workshop in 3 months' time. So if you maybe are just getting started, you try the workback book afterwards, and then you discover issues and you want to see the presentations again, then you can certainly welcome to join that again. That'll be mid-October. Within the UK Data Service, we're developing a set of learning modules which will cover different ways of using census data, some of the background to how the census data was created, looking at some of the issues of how you manipulate the census data. There is a UK Data Service help desk where you can ask questions you have. And as I say, because the UK Data Service census support is distributed among different organisations, we have different areas of expertise. So my particular expertise is like the census geography, and how you compare census data over time and cope with changing geography. How you do a lot of geospatial data manipulation. Other guys in Manchester are more knowledgeable about the actual census stats themselves, and how you pick the right census stat for your particular research question. But if you send a query to the help desk, they'll do some triaging and will make sure it gets routed to the most the best person within the census team to answer your specific question.